Let's move on to the next example, fork3.c. So this example is to explain one of the reasons why forking is a very nice idea to create a new process instead of directly loading a new process. So check this one. So here we have fork operation to create a one child process, and let's skip over this part. Then this is a very typical example that create a new process and run the hello, and the parent wait for the child process to be terminated, and if the child process terminate, then parent process terminate. This is very typical, but it have a few line before the child process executes exec to load the hello image to the process. I told you that when this operation get executed, then the memory image is replaced by the hello. But although the instructions are replaced by the hello and the memory images are replaced by the hello and the current process, which is the child process, the most of the all the contents of the child processes are gone and overwritten by the hello, but some portion of the child process remains, especially the portion that relate the child process to operating system. Those parts are related. So you can set up some process environment before loading this program. So this is one of such a setup. So here, after the child process get executed, then first it opens up the file hello.out. So hello.out, and this is a more native way to open a file than fopen. Once we know the file open the file opening API fopen, and we give a path, and then what? And then we indicate the write or a pan or read. And when we say write, then it is usually translated in this way. These are bits, so bit flag that indicate writing only, and this is a logical OR to combine these two flag at the same time and create, which means that if there are hello.out already exists, it open up write only mode, and if there is no hello.out already exists, then create one, and this one give a permission to the file for that. So this is more like native way to open up a file. Then the return value is one integer, interestingly, and this integer is a key for that file, because the file is not exactly speaking opened by this program, but it is opened by the operating system. And when we need to access this file, we always need to go through the operating system. We will see more details about the file reading and writing system API. And the truth is that we don't know anything. Application program do not have any details of the file in its internal structure and how it is stored. All the read and write is through this operating system by the system calls. So we here say that I want to write this onto the file, then we give a string and this integer number to the operating system. Then the operating system check that integer number to indicate which file do you meant, and then take your string and write the string on the file. And how that happens, we don't know. Application program do not know. Operating system absolutely hide all the details, but offer such a services. Anyway, this is the integer that indicate a file. Okay, so you can see that once you can understand in that way. So for this open the file, the operating system simply call the file one integer, typically a very small integer, like a 4, 5. Then 5 afterward refer that file. Anyway, so we here open up a hello.out, and this is very interesting. this is another system called duplication, file duplication. And this is a file duplication too, because there are various variants of the duplication system called, and 2 means the second version, and fd is the just created file, and 1, which means that for the file descriptor number 1, this is the target, duplicated fd, this is just created file for the file description number 1, which means that fd is also integer that actually indicate an open file in a kernel space. And this duplication means that for that file that is indicated by integer fd, let number 1, another integer in here, number 1 to indicate the same file as fd. It's basically duplicate the file descriptor. We call such a integer as a file descriptor, which means that fd by the file that was referred to by fd is now available to be referred with the integer number 1. And you know what it means by integer number 1. Integer number 1 is what? Standard output. So when you write on something, so for example printf, then it ultimately write on a file whose file descriptor is number 1, which is standard output. Standard output is, more exactly speaking, a file that is open whose file with the file descriptor number 1, which means that now we are replacing the standard output with this just opened it file, which is ultimately linked to the hello.out, and then close the fd. Then this one does not close the file that is open for the hello.out, but this one only reclaim a file descriptor fd. Fd is in this case is, I bet it is given as a number 3, because any process have a by default file descriptor 0 that indicates standard input, 1 standard output, 2 standard error, and that is it. And once we open another one, then it will receive number 3. Yes, right. And here close means that we are giving up the number 3, but it doesn't mean that it actually closed this hello.out, and it will not close. Why? At this moment, number 1 also indicate this exact file. Anyway, and then execute the hello. Then what will happen? Hello program will be loaded and get executed. And hello is to print out hello to the standard output. Then where the hello will appear. Let's see. So you see that hello is not printed out on the screen. Why? Because hello was printed out on the standard output of the child process, and standard output is now linked to hello.out. So hello is here printed. That's how it goes. So what this example indicates? So this example indicates by forking, after creating a process, we can set up some environment for that process before loading instructions and starts to do some functionality. And this setup can be made such that the parent process and child process can cooperate well. And by this setup, it's possible once we write a program that work on a standard output and standard input, that receive input from the standard input and print out the result to the standard output and so on. If we make one program in the standard manner, then we can easily plug such a standardized program by using this type of a system calls to set up the process and make it cooperate with its parents or other processes. So you will have a better understanding what type of interfaces are given at the Unix to make such a process-to-process communication can be easily made. Okay, and we will see that by similar feature, by utilizing a file, we can make the child process and parent process can deliver the data more conveniently, and also exchange messages so that they can make orchestration and also cooperation together by while utilizing the concurrency offered by the multiprocessing of the operating system. So this is a very, so far I have talked about how to use a fork, which is a very primitive operation for creating a process, and also how to utilize EXSL, which is to load the image, and also wait operation to synchronize the termination of the child process and parent process execution. And here I gave a brief introduction to um, a system call that is related to file so that the child process behavior or the result of the child process can be directed by the parent process.